All right, thank you for joining me. I just wanted to give another lesson on reducing fractions. You could say that reducing fractions is as easy as pi. I like fractions because there's usually pizza and cake involved. So one of the questions is to reduce or not. Yesterday we spoke a little bit about why we would reduce fractions. Essentially, it takes big fractions that look like really big numbers or that are represented with very large numbers. And when you break them into their simplest terms, they become more familiar and easier to work with. So to determine if a fraction can be reduced or simplified, you have to examine the numerator and the denominator. Now, if you'll remember, the numerator and the denominator are as such. Okay, we've got our numerator on top, abbreviated as num, please excuse my abbreviations. And then we have our denominator on the bottom. And what this is essentially saying is that out of 10 pieces, we only have 8. So let me quickly draw a pizza. Think back to my Boston pizza days when I used to cut pizzas into 10 slices. Hopefully I still have it. Oh, there we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. 10 slices. So what this is saying is that out of the 10 slices, I have 8. So someone helped themselves to 2 pieces of this pizza. This is what this fraction looks like over here. We've got 2 slices missing. So what they're saying is if the numerator and the denominator have a common factor, then your fraction can be reduced. So there actually is another way that we can write this fraction. We do have the 10 slices, but we can write this in a different way. We'll find out how to do that here. Okay, so let's look at these two fractions. We've got 2/8 and 4/9. So first we have to look at the numerator and the denominator. Do they have a common factor? And the easiest way and the most thorough way to find the common factor is to write out the factors. So for 2, we've got 1 and 2. For 8, we have 1 and 8 because a number itself and 1 are always factors. And then we know that 8's an even number. So 2 is a factor. And then 2 times what number equals 8? That number is 4. This is our complete set of factors of 8. Okay. So if we look and we see what numbers are in common on this list, well, we see 1. 1 is always going to be a common factor, so that's not a good one to choose. But we see 2 is also a common factor between 2 and 8. So what we have to do is choose this common factor, and we're going to divide both the numerator and the denominator by this common factor. And what do we get? We get 1, because 2 divided by 2 equals 1. And then we get 8 divided by 2 being 4. So look at that. We've actually reduced our fraction to its lowest terms. What about 4 and 9? Whoops. What about 4 and 9? 4's factors, we've got 1, 2, and 4. 9's a prime number, so it's only 1 in itself. We look at this list, the only common factor is 1, and we don't even consider that a common factor in the math world, so we're not going to use the 1. Therefore, 4 and 9 do not have any common factors, so this would be its lowest terms. Same thing with 1 and 4. So let's look at this guy right here. We'll write out the factors. For 1, it's just itself. And again, we've got 4's factors up there, 1, 2, and 4. The only common factors are 1, and that's not really a common factor at all. So this term here, 1/4, is actually in its lowest terms. And this summarizes what we had just said here. Since 4 and 9 don't have that common factor, the only common factor is 1, and that doesn't count. It doesn't get you anywhere, because if you divide by 1, you still get 4. So you end up with 4/9 anyway. It's stating here that 2/8, they do have a common factor, and this fraction can be reduced. We've done that already. Okay, and this is nice. It kind of really outlines what we did. So for 2 and 8, the common factor for both 2 and 8 is 2. We checked our factor list, 1, 2, 1, 8, 2, and 4. And we determined that 2 is the best factor to go with. It's also the largest common factor. That's a good strategy to be using. Okay, so we divide the numerator. So 2 divided by 2 is 1. 8 divided by 2 is 4. It looks a little bit confusing because they're representing division as fractions, which is essentially correct, but it's just saying what I had said in a different way. I like to use the notation of the division sign because it really outlines that what I'm doing to the top, I'm also doing to the bottom. And that's super important when we're dealing with fractions. So our reduced fraction is 1/4. Okay, so we have to double check. Once you've reduced a fraction, it's important to double check that it's simplified all the way. So we just have to look at our new fraction and determine if the numerator and the denominator have any more common factors. And I'm just going to write this out here. 2/8 is equal to 1/4 because this statement is true. We didn't do anything to the amount that is represented. This is still 1/4. Let me just quickly draw some pi. Again, I love fractions because we have so much pi involved. Okay, so I've got my pie cut into 8 slices. And let's say you only have a few people show up to your party, so you only need to cut 4 slices. Same pie, same apple pie, same size. Of course, my drawing isn't perfect, but if you look at this amount of pie that's shaded, we've got 2 out of 8 pieces of pie shaded. Oh, look, we have the same amount of pie if we just have 1/4. So these fractions are what we call equivalent. That's why we write the equal sign. They equal the same thing. They're just said in different ways. So we'd written out the factors of 1 and 4. We've got 1 just itself, 1, 2, and 4. 4 is a perfect square. So the largest common factor we have here is 1. And like I said, 1 isn't really a common factor at all because it does nothing. Look, we have the same fraction. So therefore, we can say that 1/4 is fully reduced. So let's see if we can reduce these fractions. 2 out of 3, let's write out the factors of 2 and 3. Well, the only common factor is 1, so nope, cannot be reduced. 4/7, 1, 2, and 4. 1 and 7. 7's a prime number, so whenever you see prime numbers involved, you can kind of go, kind of have the instinct that it likely can't be reduced. Not always, but that's kind of a nice clue to have. So again, the biggest common factor there is 1, so nope. 5 and 15. Okay, this looks hopeful. This looks promising. Like I had said, there's a prime number, but 15, we write out our factors of 15, whoops. We see that these have 5 in common. Awesome. Okay, so then we can actually reduce it by 5. So we're going to take our numerator and our denominator. We're going to divide both the top and the bottom by 5, which is going to give us 1/3. And then we can check again to see if 1/3 is in lowest terms. Whoops. I want to write that out again. I'm just going to write out the factors of 1. We've got 1 and then 1 and 3. Again, 1's the biggest one, so 1/3 is it. Usually if you see a 1 in the denominator, I shouldn't say usually, always, if you see a 1 in the numerator, pardon me, your fraction's in lowest terms because that common factor of 1, or the only common factor being 1, won't get you anywhere. So if you see a 1, you're done. 8 and 12. Let's quickly write out the factors of 8 and 12. Okay, 1, 2, 3, 4, 6, and 12. Okay, let's look at the biggest one we have in common. That's another strategy. It's always best to go with the biggest common factor because you can go with 2, no problem, but you're just going to have to do more steps. So we see here that 4 is actually the biggest one on our list. Super duper. Let's divide both the numerator and the denominator by 4. And we end up getting 8 divided by 4 is 2. 12 divided by 4 is 3. We've got 2 prime numbers. Okay, they don't share any common factors, so 2 out of 3 is our lowest reduced term. Let's look at another example. We've got 12/16. Oh, it's given us our answer, but that's okay. So we know that 12 and 6 have common factors. Well, they're both even numbers, so they will certainly share 2. We'll just quickly write out the factors of 12. If you're wondering, how do I know this factor magic? It's just practice. And it's really important to just try to become familiar with your factors as much as possible, especially for like lower numbers. Anything under 100 should hopefully kind of become second nature. Yes, okay. So we have our list of factors for 12 and 16. Again, best strategy is to pick the biggest number on this list. And if I'm scanning, I see that 4 is the biggest number. However, let's just see if we go with 2. What happens if we go with 2? Because 2 is also common. I'm just going to show you why it's better to go with the bigger number. So you got 12 over 16. We're going to divide both of them by 2. Here you get 6 over 8. That's what we have down here. Okay, good. Nice. 6 over 8. All right, let's check those factors. We've got 1, 2, 3, and 6. 1, 2, 4, and 8. Okay, so we've checked our factors. We do see we have another number in common, so we have to reduce again. So let's choose this 2. Divide the numerator and the denominator both by 2. You always do the action to both sides, or else you're going to be in trouble. It won't work out so well for you. Okay, so 6 divided by 2 is 3. 8 divided by 2 is 4. Great, we've got a prime number on top, so that kind of tells me that we are maybe done. Let's just check our list of factors, and nope, nothing in common. 3 to 4 is done. Okay, so let's just say what if, instead of doing the steps twice, let's see if we can just maybe be a little more concise, a little bit quicker. Let's just choose this common factor of 4 instead and see what happens. Okay, so 12 divided by 4 is 3. 16 divided by 4 is 4. Would you look at that? Would you look at that? We only had to do the step once because we went with the greatest common factor, right in the title there. So it's always best to go with the greatest common factor because you're going to save more work for yourself in the end. For students who are still warming up on divisibility rules, if you see a super large number and you notice that, or super large numbers in a fraction, you notice they're both even, you can always just start by dividing by 2 just to get smaller numbers, and then you can play with your divisibility rules a bit easier, especially if you're looking for divisibility by 8 and 4. Okay, so I just went over this. We've got a greater common factor of 2, but instead, if you go with the greatest common factor of 4, it's more efficient. You get to your answer a little bit quicker. So let's quickly do these ones here. Can these fractions be reduced? 1, 2, 3, and 6. 1, 3, and 9. Okay, let's choose our greatest common factor, which is 3. 6 divided by 3, that's not a very good 3. 6 divided by 3 is 2. 9 divided by 3 is 3. So we're done there. Because 2 is a prime number, 3 is a prime number. I know that this is the smallest factor because of the 2 prime numbers. 4 and 12. 1, 2, and 4. My 2 is a little hat there. 2, 3, 4, 6, and 12. Whoops, that's a lot of factors for such a small number. Again, we're going to go with our greatest common factor, which is 4. 4 divided by 4 is 1. 12 divided by 4 is 3. And 1 over 3, you got a 1 in the numerator. It's the smallest. What about 9 and 10? Well, here we have 1 and 9. 1, 2, 5, and 10. They don't share any common factors, so 9 out of 10 is already in lowest terms. I'm just going to write nope. And again, with 5, we have this prime number on top, so that's going to give us some issues. Unless 8 is divisible by 5, I should clarify that. If you have prime numbers, it's not always going to be, okay, I'm done. But if 5 isn't a factor of 8, then you know automatically that you can't reduce it anymore. So yeah, this can't be reduced. So this question says, can you get the same answer for reducing a fraction if you use common factors instead of a GCF? Yeah, you totally can. You're just going to make more work for yourself. This isn't a bad idea if you have a huge number like 2,766 all over 9,640 and you're like, okay, well, I'm just going to divide by 2. And then you can get to some smaller numbers that might be easier to work with. But we'll do that example another day. We're almost out of time here. So I hope this cleared things up for you. Hope you get lots of practice in. And if you have any questions, don't ever be shy to ask. Thanks.